Hello everyone, thank you for watching this video. In this video we are going to see how we can set up Celery with both Python and Node.js interchangeably. Celery is an asynchronous task queue system. Basically, it's a mechanism that allows you to distribute your work across different threads, processes, or even machines. To simplify, we are going to say that Celery has four main components. A worker, it's the unit of work responsible for task execution. Client is the entity that asks Celery to perform a task. Message broker takes the order from the entity and delivers it to the worker to execute a task. And the results backend. Once the worker executes a task, the task's result is stored in the results backend and can be retrieved later by the client. So let's check out these components in our schema again and see how they interact with each other. So in our schema, we have clients. We will have in our setup one Python client and one Node.js client, JavaScript client. We have a message broker. We are going to use Redis for the message broker. We have two workers, one for Python and one for JavaScript. The one for Python contains tasks written exclusively in Python. The one for JavaScript contains tasks written exclusively in JavaScript. And then we have a results backend. We are going to use also Redis for our results backend, since Redis can play both roles. A typical use case for this architectural pattern will be the following. You are building a machine learning SaaS product. You have two teams, one data science team and one dev team. The data science team knows only how to manipulate Python, and the dev team knows only how to manipulate JS. And you want to expose the work done by your data science team to your dev team, as it can be integrated into the product. And you want also to expose some tooling done by your dev team to your data science team. So this pattern is extremely helpful in this kind of case. So let's check out our code base and see how it looks like. Okay, so we have here two folders, one for Python and one for Node. Each one of them has a worker. A worker plays the role of a server, listening on a queue to receive a task and to execute a task. And our tasks are organized in packages. For example, here we have the package example containing the module arithmetic. The module arithmetic contains two functions. The same goes for Python. We have a worker here, we have the package example, we have the module arithmetic containing two functions. Okay, so to test that, what we are going to do now, we are going to start the message broker, both of the worker and the results backend in a Docker Compose environment. And we are going to send tasks for both of the workers from the Python clients and from the Node.js clients. And the clients will be external to the Docker Compose environment. So let's do that. Okay, let's check out Docker Compose file. Let's see. Okay, so in the Docker Compose file, we are starting a Python worker, a JS worker, and the Redis that's gonna play both roles of the message broker and the results backend. So we have started Redis, we have started the JS worker and the Py worker. So now we're going to do our tests. So I'm in. Okay, we are starting with Node. Let's check our Node client. So our Node client will send two tasks, one for the JS worker and another one for the Python worker. So let's execute. Okay, we have our results. We see we receive some logs here. Let's do the same for Python client. So the same goes here. We have two tasks, one for the Python worker and the other one for the JS worker. Great, so it works, and we are seeing that the logs, the task operation appeared in the log. Thank you for watching this video. I hope you like it. A GitHub link repo will be provided. Thank you.